Hello and welcome to the ICST Ambisonics YouTube tutorial series. In this video I'll have a look at how we can send and control data between our plugins and other applications, such as for example Reaper, Touch OSC or Max MSP. We will be doing this by using a protocol called OSC. I will explain how it works and show examples for specific use cases. If you already know how OSC works, feel free to jump ahead where I will show how we can activate OSC in our plugins and how we can work with it. This is not a tutorial on the technical aspect of how internet protocols work, so I will only talk about the parts that are necessary to understand for using OSC with the ICST Ambisonics plugins. OSC is an acronym that stands for Open Sound Control. OSC is an acronym that stands for Open Sound Control. It was developed in 1997 at the Center for New Music and Audio Technologies, CINMAT, by Matt Wright and Adrian Fried. It is something like a more modern and flexible way for applications to communicate over the network. Using UDP, we can send data in the form of messages and arguments to a destination, for example another device or another piece of software. Each device can be addressed by a specific IP address, and different parts of software on this device can be addressed separately by using a port number. We can also send OSC messages between different applications on the same device, which is what we will do in this tutorial. For the sake of this tutorial, you can think of the IP address as being similar to the address that you write on a package that you want to send to someone using the postal service. You need to specify where you want your package to end up so that the postal service can deliver it correctly. There are mainly two types of addresses being used, IPv4 and IPv6. For sending OSC data, we are mainly interested in the IPv4 address, which, in human-readable form, is comprised of 4 numbers that range between 0 and 255 and are separated by a period, as for example 192.168.187.1. Using this address, you can identify and address different devices on the network that your device is also connected to. To address another piece of software inside the same device, you can use the loopback IP address, which is always 127.0.0.1. This address allows you, for example, to send data from the ICST Ambisonics plugins to Reaper and vice versa. One example of what we can use this for is to make a touch interface using Touch OSC to control the position of our source points and other things in the ICST encoder. Now we know that we can use our local IP address 127.0.0.1 to send messages inside the same device. But we don't necessarily want to send our data to all of the software of this device. This is where ports come into play. To go back to the parcel metaphor, while the IP number is our address, we also maybe don't want all of the people living at this address to receive all the messages that are being sent there. So we can specify a port so that our message arrives at the right destination at the given address. For example, if we use 2 or more encoders, we can make them listen to 2 different ports so that we can address them individually and so that they don't get flooded with unnecessary messages. Even though the port numbers range from 0 to 65,535, it is generally advisable to use ports starting at 8,000. To establish communication between the ICST Ambisonics plugins and Reaper, we first need to activate it. In Reaper, go to Settings, then scroll down to the tab Control/OSC/Web and click Add. Then select OSC as the control surface mode and set the mode to local port. You can set a name, also set the port, or just leave the one that is already there. To activate OSC communication in the ICST Ambisonics plugins, we open the plugin settings and navigate to the OSC In tab. Then we can set a port, which is 50,001 by default. This port has to be unique, so if you want to add more encoders later on, just increment this number for the next plugin so that the first one has 50,001, the second 50,002, and so on. Then activate the option Receive OSC. Now we have established the communication between Reaper and the plugin. The plugin can now also receive messages sent from other software that is sent to the IP address 127.0.0.1 and the port of the plugin, which in our case is 50,001. Now that we have enabled the OSC messages for both Reaper and the ICST Ambisonics plugins, we can look at what OSC actually looks like. While the combination of IP address and port number allows us to address a specific piece of software on a specific device, we still want to control specific parts of that software. So, for example, in Reaper, we might want to control the volume of a specific track, or in the ICST plugins, we might want to control the position of a specific source point. We can specify which part of the software we want to address using the OSC address pattern string, which is a combination of different containers of controls. This is followed by one or more arguments, which is the actual data we want to send to the specified destination. As you can see in this example, the address pattern starts with a / and each part of the pattern is separated by another /, and there should be no spaces in this address string. This address tree is another way to represent how the address patterns comes together, where each of the containers and methods should be separated by a /, and this is followed by an argument or a value. In this more concrete example, we can see that we want to control something that has to do with the tracks in Reaper. Then we need to specify which track exactly we want to address, so here track number 3 or track 1, followed by the actual control of the track, so either its name or its volume or whatever else you might want to control. In the case of the volume, we might have to add even a layer more, where we say how we want to set the volume, so here in decibels instead of something else like from 0 to 1. So these addresses would, for example, set the volume of the third track to 85 decibel and the name of the first track to bird_4. Here we can see how we would write that in our OSC format. So track 1 is set to bird_4, track 2 pan is set to 0.33, track 3 volume in decibels is set to 85, and so on. The arguments that follow the address pattern can be one or more integers or floats and strings. For example, to set the x and y and z coordinates of a source point in our encoder simultaneously, we can do that in one single address. The OSC addresses could be anything as long as they conform to the OSC protocol, so that there is no space in the address pattern string and that the containers and arguments in these address patterns are separated by a /. But there are many address patterns which are already fixed, like for example these ones to control different parts of different tracks in Reaper. There are also wildcards that can be useful. A wildcard is like a variable, so that it is filled with anything that might fit in this specific position. The top address string, for example, uses the OSC wildcard, which is an asterisk, to address all the tracks that can currently be addressed in Reaper. This would rename all the tracks to whatever argument is sent with this address pattern. This message would rename all the tracks to whatever argument is sent with this address pattern. Here, the bottom address string would, for example, rename all of the tracks in Reaper to the names that we have given to the sources in our Ambisonics encoder if we replace the second part of the address with a formula that inserts the correct index there. We will look at how this can be done a bit later in the video. Finally, there is a Reaper-specific wildcard, which is the @ symbol, which is used to target the last touched track. Now that we have learned in theory how we can address a piece of software using another piece of software using IP addresses and port numbers, and how we can construct OSC addresses to target specific parts of this software to control it. Let's look at how we can actually implement this for the ICST encoder. First, we will go into the settings page of the encoder and navigate to the OSC in tab, which is where we can control which OSC addresses the plugin listens to and how this will affect the controls. If you have not yet activated the Receive OSC, do so now. Then we can add a new address that we'd like to receive. By default, this will be active and set to /demo /I and then two arguments x and y, also both in curly braces. In the ICST Ambisonics plugins, the curly braces are specific variables where the I in curly braces will be replaced by an index with which we can address a specific source, while the x and y in curly braces will be replaced with the corresponding coordinates we want to set this point to. To change this address pattern, we can directly type in the OSC message field. Let's replace the first part of the pattern with source so that we can control the x and y coordinates of a source. I have already prepared a Touch OSC interface which sends some OSC messages. As you can see in the settings of the Touch OSC app, it is sending to the host 127.0.0.1, which is our local host. That is the address being used to send the data inside the same device, which is what we want to do here. Additionally, Touch OSC is sending to the port 50001, which is the same port that our encoder is listening to. This is important, as otherwise our plugin would not receive the messages. Touch OSC is receiving messages on the port 8081, so that if we want to send messages from the ICST plugins to Touch OSC, we would have to send them to this port. If we now click on Show OSC log in our encoder, we can see that the number of things happens once I move the cursor in Touch OSC. The log shows us that it has received a number of messages. These are the messages that I pre-configured in Touch OSC. The first one we received was source 1 followed by the x and y coordinates. The second message we received was unknown to the ICST encoder. The reason that this second one was unknown, while the first is colored in green, is that we have made the encoder listen to this specific address by typing /source/ curly braces I, x, and y. So if we receive something like /source/1 and then some floats, the curly braces will be replaced by these numbers, and the encoder recognizes the message and sets the position of the first source point to these coordinates. The second message, namely /source/1/name, followed by the string name1, was not recognized because we didn't yet add this to the messages that we want to listen for in our encoder. This is then just ignored until we add it to our messages, which we will do a bit later in this video. The second thing we can see if I move the cursor in Touch OSC is that our message in the encoder lights up green for a moment. This is an easy way to tell that we have written the address correctly and that we are receiving messages through this address. The third thing that we see is that now I can move the cursor in Touch OSC and it will move the source point in the encoder accordingly. At the top of the plugin, it says unknown OSC message received, but we can just ignore that for the moment, as we know that the unknown message is the one that we didn't specify yet. If you see this and you don't know what it is, you can just open the settings and open the OSC log in the OSC in tab to see which messages are read and what the content of these unknown messages are. Another thing that you can see is that when I change the OSC address in Touch OSC to target the second source point, it is still recognized because the I in the curly braces in our OSC path is just being replaced by the number that it receives on this position of the path. In this way, we can control the coordinates of many points by using just one address, and we don't need to write one for every source point. At this point, we can already see the big advantages of using OSC over using MIDI. This was part 1 of this tutorial. In part 2, we will take a further look at how to use OSC with the ICST Ambisonics plugins.